Now let's summarize what we have learned so far. This highlights the main differences between congruency and similarity. Congruence requires both the same shape and size. This means that all the corresponding parts must be equal. You must have equal sides, equal angles, and everything identical. Congruence, think of it as like identical twins that are exactly the same. The similarity test is a bit more flexible. It requires the same shape, but it allows for different sizes. The corresponding parts must be proportional, but it doesn't have to be equal. The angles still need to be equal because angle determines the shape, but the size can be scaled up and down as long as they maintain consistent ratio. Now here's a crucial relationship that students often find confusing. We highlight this in the orange box. All congruent shapes are similar, but not all similar shapes are congruent. If two triangles are congruent, they have identical sides and angles, but identical sides are also proportional. They just happen to have a scale factor of 1:1. So, congruent triangle automatically satisfy the requirement for similarity tests. However, the reverse is not true. If two triangles are similar with a scale factor of 2:1, they have the same shape, but different size, so they cannot be congruent. This is a bit similar to what we learned last time, like how a square is a special kind of rectangle, but not every rectangle is a square. Now let's do some practice with these questions. Let's look at triangle ABC and triangle DEF. Are these triangles congruent, similar, or neither? Take some moment to examine the measurements. Triangle ABC has sides of 5, 6, and 7. The triangle DEF also has sides 5, 6, and 7. For congruency, we need all corresponding sides to be the same. So we can check that AB equal to DE, both are equal to 5, BC equal to EF, AC equal to DF. Since all three pairs of corresponding sides are equal, we can conclude that these triangles are congruent using the SSS congruency test. Do they are also similar? Yes. Remember that we have said that all congruent shapes are also similar. Since we have proven that the triangle are congruent, they are also automatically similar with a scale factor of 1:1. So the answer is yes, these triangles are congruent, and because they are congruent, they are also similar. Now for this triangle, are they congruent, similar, or neither? Notice that these two triangles have the same angles. 90, 45, 45. So three sets of angles are corresponding and the same. In this case, the triangles are similar by the AA test. When two angles are equal, we know that the third angle are also equal by default. So these two triangles are definitely similar by the AA similarity test. However, without any side length information, we do not know whether this triangle is congruent. They could be the same size or one could be larger than the other. All we can say is that they are similar. How about this one? Are these triangles congruent, similar, or neither? You can see that we have two sides measuring 8 units each, and both have a 50-degree angle. Now the key question is that where is this angle located? You can see that this angle is at vertex A for triangle ABC, positioned between the two sides AB and AC that measure 8 units. In triangle DEF, the 50-degree angle is also positioned between sides DE and DF that both measure 8 units. So we know that AB equal to DE equal to 8, AC equal to DF equal to 8, and the angle between the two sides, angle BAC equal to angle EDF equal to 50 degree. So we can say that a triangle ABC is congruent to triangle DEF using the SAS congruency test. Remember that once you fix two sides, and if the angle is between, note that the angle will be in between the two sides, the triangle shape and size are completely determined. There's only one way to complete the triangle. Now let's look at these two triangles. Are they congruent, similar, or neither? Triangle ABC has sides 5, 4, and 3. And then we have triangle PQR with 10, 8, and 6. Are these sides equal? Clearly they are not, so they cannot be congruent. But we can check whether they are proportional to each other. So AC to PR is 3 to 6 equal to 1 over 2. BC to QR equal to 4 over 8, which is 1 over 2. And lastly, AB to PQ equal to 5 over 10, which is 1 over 2. Since all the corresponding sides have the same ratio of 1 over 2, we can conclude that these triangles are similar, but they're not congruent. How about these two triangles? Are they congruent, similar, or neither? We look at them carefully. Both triangles have a 60-degree angle and 50-degree angle. And since the angle in any triangle must sum up to 180 degrees, we kind of know that the angle must be also the same, 70 degrees. That is from 180 minus 60 minus 50 equal to 70. So we have all three angles the same. Then we look at the sides. Both triangles have a side measuring 10 units, MN and PQ. So we can see that by AAS, they have two equal angles and a non-equal side. So these two triangles are congruent. To summarize, since we have two corresponding angles equal and one corresponding side equal, conclude that triangle LMN is congruent to the triangle OPQ. How about these two triangles? Are they congruent, similar, or neither? Let's look at them carefully. We notice that both have right angles, and then both have hypotenuse measuring the same unit. So your first instinct will probably to try to use the RHS test. For RHS, we need the right angle to be the same and hypotenuse to be equal. But we actually also need one other pair of corresponding sides to be equal. In this case, we had the first two conditions met, but we're missing the last three pieces of information. Therefore, without knowing at least one more pair of corresponding sides, we cannot determine whether this triangle can be congruent. They could be congruent if, for example, MN equal to PQ or if NO equal to QR. But they also could be completely different if the sides do not match. Now let's look at this problem. Are these triangles congruent, similar, or neither? Triangle LNM has side measuring 12 units, and I can see another measurement of 20 on one side. And then triangle OQP has sides measuring 15 and 25. Let's find out the ratio. 12 to 15 will be equal to 4 over 5, and they're also equal to 20 over 25. Since we know that the sides are all proportional with the same factor of 4 over 5, these triangles are definitely similar. However, do we know whether they are congruent or not? They are definitely not congruent. Even though they have the same right angle, they have different hypotenuse and they have different length on the side. Therefore, the triangles are similar, but they are not congruent.
Smash your maths exams. Download Learn Maths Today for real exam questions and achieve top marks.